In step 3 of exercise number 6, the following actions have to be implemented to complete the machining of the ledges. An iRough and iFinish operation must be defined. During this exercise, making changes to the milling levels and its effect on the technology wizard is explained in detail. First, you have to define the rough machining of the ledges. Add a new iMachining operation. In the SolidCAM manager, right-click Operations, Add Milling Operation, and select 2D iMachining. The iMachining operation dialog box is displayed, and the default iRough is used for technology. On the geometry page, click the New button to define the machining geometry for the ledges. For this operation, the geometry is defined as an open pocket with island. In the SolidWorks graphics area, pick on the bottom edge of the target model as shown. Select Auto Constant Z to close the chain, and then click Yes to confirm the chain selection. The chain icon is displayed in the Chain List section. Right-click Chain 1 and choose Mark Chain as Open. Next, pick on the top edge of the target model wall as shown. Select Auto Constant Z to close the chain, and then click Yes to confirm the chain selection. The geometry is defined. Click OK to confirm the geometry selection and exit the Geometry Edit dialog box. Switch to the Tool page and click the Select button. For the purpose of this exercise, you have to define a new tool. Click the Add Milling Tool button to start the tool definition. Select Bullnose Mill from the Milling Tools list. Under the Topology tab, set the diameter value to 14 mm and enter a corner radius value of 3 mm. Set the remaining tool parameters as follows: total length 90 mm, shoulder length 40 mm, and cutting length 35 mm. Change the number of flutes to 4. Then, switch to the iData tab and change the helical angle parameter to 35 degrees. Click the Select button to choose the tool for the operation and exit the Part Tool table. Switch to the Levels page to define the milling levels. Click the Upper Level button. In the SolidWorks graphics area, select the top face of the target model as shown, and then click OK to confirm the selection. Next, click the Pocket Depth button and select the lower face of a ledge as shown. Click OK to confirm the selection. Switch to the Technology Wizard page to view the cutting conditions. Looking at the step-down output grid, the wizard automatically calculated one step down to achieve the total depth. The ACP indication is 1.8, and the field is painted green for good stability. With a machining level aggressiveness of 6, note the output cutting data values generated by the wizard. Looking at View 1 and View 2, the following sets of data are provided based on the tool information and milling levels defined for the operation, as well as the machine and work material definitions. Like changes to the tool definition, it is important to note that changes to the milling levels can also dramatically alter the cutting conditions being calculated by the technology wizard. For example, switch to the Levels page. Changing the upper level, pocket depth, and/or delta depth values will have an effect on the output cutting data unless the step over is at its maximum already. Switch back to the Technology Wizard page. Changing the pocket depth will affect the output grid, and in turn the output cutting data since the total depth is used by the wizard for calculating values. Even changing the mode for calculating step down can have an effect on the output cutting data. For example, set the radio button to user defined. Using number of steps, enter a value of 2 in the input field text box. Looking at the output grid and output cutting data, you can see that the cutting conditions being generated by the wizard are altered accordingly. The wizard calculates step over based on the depth of cut or step down, and spindle speed and feed rate are synchronized based on the step over. For the purpose of this exercise, change the mode for calculating step down back to automatic. Switch to the Technology page. By default, a 0.24 mm allowance will be left on the walls. At this point, the operation can be calculated and the iMachining toolpath can be viewed on the model. Name the operation iRough Ledges. Click Save and Calculate, and then click Simulate. Click the play button to view the iMachining toolpath at work. The tool approaches from the outer chain and performs the rough machining of both ledges, collapsing towards the interior walls. Close the simulation control panel with the Exit button to display the iMachining operation dialog box. To perform the finish machining of the ledges, you have to define an iFinish operation. Click the Save and Copy button to create a copy of the current iMachining operation. When the copied iMachining operation dialog box opens, click the drop-down menu under Technology and change the operation type to iFinish. The copied machining geometry, 14mm tool, and milling levels from the previous iRough operation are used for this iFinish operation. On the Technology Wizard page, the default cutting conditions are used with a machining level aggressiveness of 6. On the Technology page, the wall island offset is now set to 0 by default. At this point, the operation can be calculated and the iMachining toolpath can be viewed on the model. Name the operation iFinish Ledges. Click Save and Calculate, and then click Simulate. Click the play button to view the iMachining toolpath at work. The tool approaches and performs finishing of the corners first, and then finishes the walls by removing the 0.24mm offset in a single pass. Using the Exit buttons, close the simulation control panel and the iMachining operation dialog box. At this stage, Step 3 is complete, and changes to the milling levels were explained, having an effect on the Technology Wizard. If you have not followed along, apply and practice the procedures shown in this video to define the rough and finish machining of the ledges.